Well, now that we know all the interaction processes between the product and the content, the product and the package, I'm going to show you briefly some services that we offer from IMPLUS. First of all, the technical assistance that is very important related to the food contact packaging materials. For example, the advice on legislation and standards, the improvement of product properties, the failure analysis. More specifically, regarding the food contact plastic packages, we can offer packaging optimization, for example, the design and the selection of materials, the packaging failure analysis about the functionality, manufacturing problems, the analysis of odor problems in plastic packages, and maybe the most important, that is the compliance with the packaging legislation about food contact, waste management, good manufacturing practices, labeling, pharmacopoeia, and so on. The other big service that we can offer from IMPLUS is analysis and testing. In general, our tests and analysis may be classified in the following way. Identification and characterization analysis on polymers, additives and reinforcements, and residual substances. Mechanical properties, optical properties, rheological properties, physical and thermal properties, and performance against external agents. It's important to point out that our laboratories are internationally accredited according to ISO IEC 17225 standard by ENAC, the Spanish accreditation body. Specific analysis and tests that we can offer for food contact plastic materials are all the testing services to verify the compliance with food contact legislation and the product package interactions tests like permeability, migration tests, compatibility, and sensory tests.
Hello, my name is María José Badenas and I am a researcher in the chemical laboratory of IMPLUS. I'm going to give a few key ideas about the food contact legislation and verification of compliance. Migration is the release of substances from the material into food. Food contact materials should not pose a health risk or worsen nor mask the quality of the food. These aspects are covered by food contact legislation. The migration of certain substances from the packets may also cause a degradation of the packets. Here you can see the current legislation that applies to all food contact materials at European level. The selected points are the main ones that affect plastics. Regulation 1935 of 2004, which is known as the Framework Regulation, establishes the general provisions for all materials, while Regulation 2023 of 2006 establishes general provision on good manufacturing practice and must also be fulfilled by all materials. The specific measures for plastics are laid down in Regulation 10/2011. This regulation has had different amendments, 6 until this moment, and it's in continuous development mainly due to the incorporation of new authorized substances or new specifications or requirements for already authorized substances. Regulation 10/2011 establishes requirements for raw materials and for finished products. In one hand, substances intentionally used in the manufacture of plastic materials and articles shall be included in the Union list with some exceptions. Some exempt substances are subject to risk assessment before deemed compliance. On the other hand, the product in the finished form, as it's going to get into contact with food, must fulfill all applicable restrictions. The verification of these restrictions could be done both based on calculation or in migration testing. So risk assessment and migration test only occurs if deemed necessary. The declaration of compliance serves to guarantee the fulfillment of the legislation in its manufacturing states and gives the necessary information to the following states so they can proceed. It's a key document to ensure compliance of the final plastic material and article with EU provisions. Annex 4 of Regulation 10/2011 sets out the information that must contain the declaration of compliance. Anyway, due to the great variability in the content and form of the declaration of compliance of different operators, there are always questions concerning the interpretation and implementation of certain aspects of them. IMPLAS has a wide experience in the revision of declaration of compliance and can help you to obtain the right information from your suppliers. At the same time, we can advise you to prepare your declaration of compliance once your own compliance work is finished. When performing migration testing, the definition of the test required and the sample selection are crucial. Once finished the test, a correct expression of the results is also important before comparing them with the limits. IMPLAS can help you to make the minimum number of tests as possible to verify the compliance of a family of products. As already mentioned, one of the basic principles set out on the framework regulation is that food contact materials should not release their components into food at levels harmful to human health and should not change food composition. So the innerness of any food contact materials must be guaranteed. The verification of the fulfillment of these requirements can be done by means of specific and overall migration tests. Most known types of limitations set out in Regulation 10/2011 are the overall and specific migration limits. A release of 10 milligrams of constituents per square decimeter of plastic is established as the overall migration limit, above which the migration is regarded as an unacceptable change of the food. The specific migration limits are based on the safety evaluation of the substances, taking into account information on the toxicity and the migration behavior of the substance. Other restrictions can be, for example, residual content of the substance in the final product. In the plastic sector, there are industries with hundreds of trade references due to the use of different types of materials, different colorants, different additives, different combination of materials, and also different thicknesses, volumes, and formats. IMPLAS can help you to select the best samples to cover the wider range of trade reference as possible. In the same way, we can also help you to select the test conditions to cover the wider usage range as possible, advising you regarding all the possibilities and the corresponding assumed risk, so you can decide about them. As the measure of migration in food is at least complicated, migration is measured into food simulants, which represent the hydrophilic, amphiphilic, and lipophilic properties of food, and therefore the chemical characteristics that lead to a transfer of substances from the food contact material into the food. The verification tests have to be performed using test conditions defined in Annex 5 of the Plastic Regulation. Test conditions shall be selected according to the most extreme condition of time and temperature foreseeable in actual use. To determine the specific or overall migration, the test specimen is brought into contact with food simulants. Here you have various ways to put a test specimen in contact with the food simulant. For films and other flat test specimens, migration cells have been developed to achieve one-sided contact, which is the real use of them. For articles that can be filled, this is rather straightforward, as the article can be filled with food simulant and stored for the proper contact time and temperature, and then the migration is determined. Immersion can be used when the real material are used by immersion, for example kitchen utensils, or as a more restrictive way of contact in any case. Once finished the exposure period, quantification of migration is performed. For overall migration, a distinction must be done between tests with aqueous and volatile substitute food simulants and tests with vegetable oil simulant, as the method for quantification of the migration is completely different. In the first case, a direct gravimetrical determination is applied, while in the second case, chromatography has to be used to apply an indirect gravimetric approach. For specific migration, the analytical determination of migrants includes three main steps: extraction, sample cleanup if necessary, and determination mainly by chromatographic techniques. It should be mentioned that all the standards indicated, both for overall and specific migration, refer to the former EU legislation and need to be updated. Most of the specific migration tests are performed according to in-house methods developed by the laboratories. The analytical approach for specific migration will be dependent on the nature of the substances, its volatility, polarity, and functional groups, the naturity of the food simulant, if it's aqueous or fatty, for example, and the level of determination required, depending on the established migration limit. Different chromatographic techniques can be used for a specific migration test. As you can see, IM+ has a wide variety of equipment to cover a broad range of substances. To finish this part of the presentation, it's important to stand out that legislation admits the use of screening methods for assessing compliance with migration limits. The use of these screening methods can reduce considerably the number of migration tests needed. IM+ can help you to take advantage of this, thanks to our wide experience in this kind of approaches.
Hello, I'm Elizabeth Carrillo and I work as a researcher of the chemical laboratory of IM+. Why do we need to make sensory tests in the packaging material? The packaging material are not inert and can transfer substance into our products. In this context, the Regulation for Food Contact Material 1935-2004 states in the Article 3 that materials do not transfer their constituents to food in quantities which could bring about a deterioration in the organoleptic characteristic and affect the food quality. In this context, organoleptic analysis in plastic materials is required by legislation and for customer confidence. The last one means that if a strange odor or flavor is detected and it is originated by the packaging, this produces product rejection, quality damage in the brand image, damage in commercial relationships, and expensive litigation process. The most relevant standards to ensure compliance with Article 3, 1935-2004 concerning the deterioration of organoleptic characteristics of food are ISO 13302, DIN 10955 and ISO 1230. The two first standards are for all materials in direct or indirect contact with food. These standards are the most used for analyze food contact plastic materials. The last one, the ISO 1230, is exclusively for paper and board. Both standards, ISO and DIN, have the same principle. This means that samples, for example package or plastic films, are in contact with food for a time, and after this time of contact, a sensory test is applied. The contact between the material and food could be done by direct or indirect contact. For example, indirect contact, as the name says, the plastic material is in contact with the food or the food simulant. However, in indirect contact, as you can see in the picture, the chocolate is down and the material is up. For this indirect contact, an hermetic recipient and a dissolution to create an internal humidity is necessary. For example, in ISO 13302, we have a sample preparation that we call a sample exposure. The conditions to take into account are food simulants, temperature, and time of exposure of the food contact material. The conditions are selected according to the real food that is going to be in contact with the material. After the exposition, a sensory test is applied. The selection of the test is done according to the object of our product. For example, if we can detect if a material transfers a strange odor to the food, we need to compare with a blank. The blank is a food that is not in contact with the plastic material. So we can use a triangle test to detect this difference and determine if the food is perceived as different. In addition, we can also use descriptive tests in order to obtain descriptors. An example of this kind of test is a profile test. The use of a scale is also provided in ISO 13302. Panelists give a value of their perception. In addition, a scale of 0 to 4, it could be used in order to obtain a value of the organoleptic contamination. In this sense, the success of the results depends on the performance of the panel. A well-trained panel acts as a measuring instrument. Thanks so much for your attention.
Hi, I'm Victor Mocholi. I work as a researcher in the chemical laboratory of IMPLAS, and I'm going to talk about permeability. Permeability of films and packaging is a key point for preserving packaged products, especially in case of foodstuff, but also in others like cosmetics or pharma. For each product, there are some factors that will determine its shelf life. Oxygen or moisture or water vapor are two of the main factors of foodstuff degradation. When we say that a material or packaging has a particular gas permeability, for example oxygen, it gives us an idea of the amount of gas molecules that pass through the surface of the packaging material. Although in daily life there is common perception that plastics are impermeable, and this is not true, given that they allow the exchange of gases, vapors or radiation through them, according to the type of polymer used in the packaging production. Besides the nature of the permeant and obviously of its concentration, permeability also depends on other factors such as temperature, relative humidity, and of course the type of polymer, both of its composition and the shape of its structure. In terms of structure, it can affect factors such as crystallinity, molecular orientation, free volume between chains, binding bonds between chains, additives, pigments, plasticizers, and other fillers, moisture sensitivity or reticulation. In terms of composition, the polymer will have more barrier to oxygen as X radical becomes more polar. There is a relationship between the polarities of permeating gas and the packaging material and its barrier. For example, when we talk about polyethylene material, it has a very poor oxygen barrier because both have similar polarities. However, it is very good barrier to water vapor. Usually, materials having good oxygen barrier properties have worse barrier properties to water vapor and vice versa. The fact that a material has high oxygen barrier, for instance, that do not guarantee that it has a good barrier to water vapor. Materials with low permeability or gas transmission values are normally called barrier or hard barrier materials to such gases. In order to determine the permeability of a material to a particular gas, different methods can be used. The most common method in packaging applications where a high sensitivity and low permeability determination are required are those using specific sensors. In other words, the sensor used allows only detecting molecules of the gas being measured without interfering the other gases in the environment. It is possible to determine permeability both of film-like samples or complete packages like bottles, capsules, jars, etc. The most critical fact is selecting the test conditions like temperature or relative humidity. When we want to compare permeability values for different samples, a sample with its correspondent data sheet or routine quality control, it is needed that permeability values are determined in the same temperature and relative humidity conditions. Otherwise, it is not possible doing direct comparisons. What information does it provide? This test gives us the gas transmission rate through film or packaging to oxygen, water vapor, or other gases. In other words, it gives us an idea of the gas amount able to go through the film or packaging during a specific time, whether through complete packaging in the case of bottles, for example, or capsules, jars, or any tasting packaging, or film in square meters. The lower this value is, the less gas amount is able to go through the packaging material, what in most cases enlarges preservation time of packaged food or simply the product shelf life. For oxygen, the result is in cubic centimeters, while for water vapor is in grams. Permeability is especially critical in the case of foodstuff packaging, although it also can be in other cases such as in pharmaceutical applications, for example. For each foodstuff, there are different degradation factors that determine the shelf life. Oxygen and humidity, or water vapor, are two of the main factors of degradation for many foodstuff. In order to ensure the right preservation and keeping in mind this fact, it will be necessary to keep foodstuff as far as possible from degradation factors. From permeability point of view, whether easy or difficult that the molecules of determined gas get inside the packaging, it can affect the foodstuff preservation inside the packaging. And other important aspect related to quality control is to verify that permeability values keep as expected, that we have expected. Then, finally, a particular significant case in the permeability control is the modified atmosphere packaging, where it is obviously essential to control the barrier gases introduced inside the container.
So, thank you very much.